Welcome to this breakout. Hybrid and multi-cloud app security consistently protect your application in heterogeneous environments. Right now with Ali Mokhtari.
Thanks, Alexi, for the intro. Hello all, and welcome to this breakout session about hybrid and multi-cloud app security. I'm Ali, and I'm leading the pre-sales team here at Roland Schwarz Cybersecurity. Adopting a hybrid cloud or multi-cloud strategy for hosting applications is a topic that is often being discussed with our customers. We help them protecting their applications, especially when those are hosted in different locations with a common security approach. The vast majority of companies and public organizations have started with a hosting on-premise in their own data centers, premises, or at a specialized hoster with a dedicated or shared servers. The hybrid cloud approach that we will discuss today is all about combining on-premise hosting of your applications with a public cloud hosting. A multi-cloud strategy is, on the other hand, the ability to use different public cloud at once. We work with our customers to ensure they use the same security level over all of their applications, regardless of their hosting locations. Could it be AWS, Microsoft Azure, or Google Cloud Platform? There are several reasons why our customers are considering a hybrid or multi-cloud strategy. The first use case we find most often is the ability to overflow into a public cloud to manage excess of traffic to optimize costs. Indeed, the organizations wishing to upgrade their on-premise infrastructure find themselves obliged to go through internal processes again, sometimes very time-consuming, to invest in oversized physical appliances that will likely only be used occasionally. Therefore, this first use case makes sense when it comes to coping with the usual traffic load on traditional on-premise appliances and to deal with the peaks on one or more public clouds with a pay-as-you-go system, for example. This second use case allows to maintain any sensitive applications in terms of intellectual property, personal data, for example, on-premise. The rest of the public activity can be managed in one or more public clouds. And the third use case that we find, especially in the financial sector, is the possibility of leveraging the unlimited resources of the public cloud, especially in terms of CPU, to apply high-consuming algorithms. As you will see, the hybrid cloud strategy has obvious benefits and can be used for other use cases. Whether you have chosen one or several public clouds, you are certainly right because each one has its strengths in terms of agility, services, and costs. Cost optimization is certainly a triggering factor to adopt one or more public clouds. As we've seen in the previous slide, pay-as-you-go can considerably reduce the on-premise costs. Nevertheless, organizations adopting the hybrid cloud often only consider the tip of the iceberg. In choosing a specific provider, organizations often tend to build everything around that cloud. In the event that this provider increases the price of the services they use, the issue of moving from this provider to a cheaper one comes or goes back on the table, and all the time and money invested in building those configurations can be lost. Cost predictability is also an important consideration. I have personally heard several customers being very surprised to see some amounts on their invoices at the end of the month, especially when the price depends on several variables such as bandwidth, number of implemented rules, etc. The third issue is the consistency of the configuration when using multiple solutions of the same type. If I take the example of the WAF that we are familiar with, setting up a web application firewall on AWS and on Azure in parallel at the same time means investing twice as much operating and maintenance efforts. Azure WAF allows you to enable predefined rules in the majority of the cases, while it is necessary to create custom rules on AWS. And finally, the consequence of this point is skill multiplication. In addition to the expert virtualization engineers who train your teams for your on-premise environments, you will need to train them or hire new cloud expertise. The transition from on-premise hosting to a hybrid cloud strategy will therefore aim to improve processes. Today, to create a virtual machine on a virtualization server, it will be necessary to request it through an IT ticket, and this will go through a very expensive validation workflow. The same goes for creating rules for opening ports on a network firewall. These processes are likely to change in the cloud to gain flexibility and time. The public cloud also allows you to benefit from unlimited resources available at any time, anywhere. This is another important fact that will reduce processing times for some requests and then save a significant amount of time. The total cost of ownership, called TCO, is then optimized. And finally, public cloud's availability commitments, different geographic regions, and availability zones are an effective way to ensure that your applications are always available. The elasticity and scalability available in the cloud also makes it possible to support your growth in bandwidth when necessary. Our value proposition with Rohde & Schwarz Web Application Firewall will allow you to achieve all of these objectives while bypassing the challenges you may face. You will be able to adopt an agnostic security approach with Rohde & Schwarz Web Application Firewall being available in the same format on the three public clouds, AWS, Microsoft Azure, and Google Cloud Platform, with a centralization of all of your security policies. On one hand, you will be able to have a global policy consistent with your security guidelines, and on the other hand, you will be able to adjust rules as you wish in an automatic way, and I will come back to this during the demonstration. Rohde & Schwarz Web Application Firewall also leverages the benefits of public clouds with availability in all regions, with automatic scaling that will allow you to launch new instances during your traffic peaks and return to a normal configuration when the excess of traffic has disappeared. This will, of course, allow you to optimize your costs. It is also possible to deploy Rohde & Schwarz Web Application Firewall faster to protect your applications thanks to an infrastructure as code approach via Terraform, and to update your policies using our API-based configuration orchestrator. I will show you in a moment how we can use this approach to protect your applications in a couple of minutes. And finally, the different types of licensing will allow you to combine investment and subscription when using WAF instances. For example, it is possible to deploy different web application firewalls in perpetual licenses for your usual traffic and scale up via auto-scaling with pay-as-you-go instances. Please watch the following demonstration that I will perform right now. In this quick demo, we'll be using a V12 Terraform module for AWS that is also available for Microsoft Azure and Google Cloud Platform. This infrastructure as code approach aims to automate the deployment of an infrastructure in the public cloud, including all the components such as local variables in the top part of the file, and then the WAF image or AMI that would like to use the instance's role, whether it's manager or managed, the auto-scaling policy, and the security groups to control the incoming and outgoing traffic, and then the specifics of the infrastructure such as the AWS account The machine size to be used and other IDs are defined in additional configuration files. Let's apply this Terraform module now. The deployment of the infrastructure components is initialized. We then confirm the provided information is valid, and we follow step by step the creation of the different components, the load balancers, the WAF instances that will be linked to those load balancers, the security groups, the auto-scaling policy, and we finally get through this deployment in few minutes with the green results at the bottom describing the WAF administration IP address along with the load balancer public URL. And going back to the EC2 page, we'll be able to find our 3 instances deployed via the Terraform module, 1 for management and 2 managed instances. And all the other components have also been created, and we can see here, for example, the auto-scaling group, where we can also manually adjust some specifics. And as soon as the auto-scaling is triggered, we can notice that a new instance appears in this page. Let's now log in into the WAF management console in order to check if the infrastructure has been successfully deployed with Terraform. As soon as the WAF is initialized, we can immediately see 4 different entries related to the 4 different instances that we have. The 3 first entries are Biol instances, and the 4th one is a pay-as-you-go instance. Let's now provision configuration on the deployed instances using the API scripts in order to create reverse proxies, applications, and security policies. In few minutes only, we were able to deploy different WAF instances and protect different applications with the same security policy regardless of their hosting locations. Could it be on-premise, on AWS, on Microsoft Azure, or on Google Cloud Platform? Thank you for watching, and I'm encouraging you to watch the other breakout sessions. Thank you.